Okay, guys. So today, as we discussed, right, we are going to talk about numerical Python as well as Matplotlib for data visualization. Okay, so before I start, I want to hear from you guys. Have you heard about it, Numpy, anytime, anywhere?
Yes, sir.
Where exactly?
Sir, in data analytics, I had heard it in a project.
Oh, okay, yeah. So I'll tell you where exactly it is used. Okay, anybody else? Okay, so this NumPy is basically a numerical Python package in Python. So it is basically used for all scientific computation. Okay, so the major application of this is computer vision. Okay, and signal processing or audio processing, and of course machine learning, right? So whenever you see any data, it must be converted to numerical, and later it has to be processed to the algorithm. Correct. So whatever data you are going to process, everything will be in the form of array. Okay, and that array is nothing but either single dimensional array or multi-dimensional array, or it could be any n dimensional array. Okay, so let me explain few things using whiteboard, then you will understand what I'm talking. So in the list what we had seen, we were defining the value like this, right? I hope you guys remember, not forget anything. Correct. So this was nothing but a single dimensional array. I can say single dimension array. There was another list, let's say L2. We had defined like this 1, 2, 3. Then maybe there was another list inside this. There's one list, comma, another list. Correct. So this you can say two-dimensional array. Okay, so if you remember, I think in first semester or second, right, you guys would have read about matrix operation. Have you read about matrix?
Yes,
Maths 1, 2, somewhere, I guess. I don't remember exactly, but it was there.
Yes, sir.
Right? Yeah, so matrix operation, whatever you are going to learn today, right, you will realize it, how easily we can do with the help of Python. Okay, so you would have seen matrix like this, like 1, 2, 3, 4, 5, 6, correct? This is how many? 2 rows and 3 columns, correct? And this is nothing but your multi-dimensional array. So whatever matrix you see, right, you will have multiple rows and multiple columns. That is known as multi-dimensional array. And when I say multi-dimensional means it is 2D only, because why it is 2-dimensional? Because only row and columns are there, correct? Now, if I talk about 3-dimensional array, can someone tell me any example of 3-dimensional array?
3 rows, 3 column.
3 rows. Have you seen this kind of what do you say, 3-dimensional array? Any real-time example?
So cubic.
Yeah, Rubik cube. Have you heard about it?
Yes.
So what it has? It has this face, correct? So front, back, up, down, left, right, all things are there, right? So this kind of array you will be representing in the form of 3 rows, 3 column, and 3 array, different array. Why 3 array? Because let's say we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Assume that this is nothing but the front face. So we have 3 by 3, right? Yeah. So this is having some value, this is having some value, and all are having some value, right? So assume that this is nothing but your representation of 3 by 3 array of front face. Similarly, you have top face, left face, back face, right face, like that. So all, if you combine together, that will be called 3-dimensional array. So I'll tell you how you can generate with the help of NumPy array. And why this will be used, I'll tell you, let me tell you the real-time example. You have seen color image, right? Everyone have seen this color image, right? So these are having 3 components, right? Red, green, and blue. And each image is nothing but a representation of some pixel values. Okay, so pixel is having some number. Okay, so let's say we have black and white image which will represent from 0 to 255. Okay, 2 raised to 8 bit representation. Correct. So color image will be always in the form of 2-dimensional array. Okay, but when you talk about 3D, when 3 color components are added, then it will be in the form of 3-dimensional array. So a red color, you will have some matrix 3 by 3 or whatever. It could be number of pixels depending on the number of pixels. Okay, similarly for the green color, you will have another array Similarly for the blue also. Okay, all those three if you combine, that will be called three-dimensional array, and that is representation of color image. Okay, so that's what now you would have realized, like NumPy will be very helpful in the form of, like whenever you are processing any image, it could be 2D or 3D image, or whenever you have signal. So let's say you have a signal, some voice signal, something like this. Okay, so this is what, this is just a time domain, right? Let me use another image. Let's call this as audio signal, or you might read in the DSP also, signal processing, right? So you have two axes, correct? This is your time axis, and this is your amplitude axis. So you have some signal, something like this. Maybe you talk about ECG, something like this, right? So this is what, this is nothing but your time axis, and this is nothing but amplitude, correct? So whenever you represent this kind of array also, right? So in the form of array, it is nothing but just a number, correct? At this particular 0 time, you have 0 amplitude. At this particular time, let's say you have, this is 1. We have peak as plus 5 volt, because amplitude will be represented in the what is it? It's in the form of electrical signal, right? So that electric signal will be in the form of some kind of voltage. Let's say at 1 we are getting 5 voltage. Similarly here we are getting, let's say this is 2.5 voltage. This is maybe 3.0 voltage, something like that, right? So all this, if you represent in the form of array, right, this will be again a two-dimensional array. Okay, so this is like I'm just telling one example. This is also used in the audio signal. I mean, NumPy is also used for audio signal processing or digital signal processing, correct? So that's about image and this, and we have something called text. Okay, text data, let's not discuss about this. So major application will be your signal processing and image processing. Okay, so for image processing, you might have heard about computer vision. Okay, that is another library in the Python, which is heavily used for processing all kind of images, no matter it is color or what is it, black and white image. It is, I mean, large application will be developed in the form of, for industrial application. Okay, like food processing, I think in one of the video I talked about it, right? So food processing, let's say food is, getting sent to the machine, and before passing it to machine, you have to identify whether it is bad food or, correct food, or maybe it's a fruit or any vegetable, right? So based on that camera, it will capture the image, and it will identify based on the database whatever is captured, and quickly it will identify it is bad or good. So based on that, it will filter. So those kind of application will be very heavily using this computer vision. Okay, similarly, for signal processing, you might have heard about Alexa, right? Alexa or OK Google. Okay, so there it will be used, NumPy. Okay, so these are a few examples I was telling. Now let's see what and all we have here. So we'll see what is the library, how to import it, and what and all functions are supported. Okay, and how to create a single dimensional array, two-dimensional array, three-dimensional or n-dimensional array. If you have got one-dimensional array, how to reshape them based on whatever shape you want. Correct. Then we'll see how to create different kind of arrays. So you would have read about this also, right? Generating zeros, ones, identity matrix, I matrix, or empty matrix, correct? So those also we'll see. How to transpose an array. So transpose, anybody knows what it is? Where exactly it is used? How do you transpose an array or matrix? Anybody? Matrix operation you have read, right? In any other semester?
Yes, sir.
So you forgot the transpose?
Yes, sir.
Okay, so transpose is nothing but you have row and column measure, right? So row will be converted to column and column will be converted to row. That is what is transpose array. Okay, so we'll see how to generate and how to do the transpose and how to modify values. So why this modification is required, right? If you would have done some kind of what do you say, photo processing in Photoshop, right? So basically you are rotating left and right, correct, up and down, and you are editing some properties, correct? So what is happening in the background? Basically you are modifying the array values in the matrix. Okay, so we'll see with the help of some examples also. So whatever photo processing or editing you are doing, right, internally it is using NumPy array only. to do all those operations. Okay, we'll see arithmetic operations on array also, like how do you add two matrices, how do you subtract, okay, how do you divide, and we'll see linear algebra related what to say function also. So you would have heard about, or you would have used dot product. So I want to ask from you guys, what is dot product? How do you multiply two matrix? कुछ याद है कि भूल गए? Okay, let me just tell you this. Okay, so we have two matrices here, 1 2 3 4 5 6. If I want to multiply with this matrix, how to multiply? So let's say this is A and this is B. A dot B. How do you calculate? Anyone remember? Okay, you guys forgot. Okay, so what do you take? You take the first row, that is nothing 1 2 and 3, and of course this is the B, right? So you will be writing 1 2 and 3. So 1 will be multiplied by this, then 2 will be multiplied by this, and 3 will be multiplied by this. Whatever you are getting, just add them. Correct? That will be your first value. Here it will come, right, after multiplication. You keep repeating for all the rows of matrix A and keep multiplying by B. That is what is your dot. A multiplied by B is different. For that, you have to have similar matrix. Okay, so that is nothing but, let's say 1 2 3 4 5 6 1 2 3 4 5 6. Okay, so 1 will be multiplied by 1, 2 will be multiplied by 2, 3 will be multiplied by 3. Okay, that is what is your multiplication. So don't get confused what is multiplication and what is dot. Dot product will be different and multiplication is different. This is basically used for solving linear equations, right? So let's say you have 2a plus 3b plus 4 equal to 0. Okay, 4a minus 5b plus 2 equal to, let's say, 5. If you want to solve this kind of equation, that's where your dot product will be used. Okay, so yeah, that's a short intro about like what you forgot, right? Dot product and multiplication of the matrix. So that's what we are going to see here, and how to iterate over multiple values of the array. Okay, so iteration we have seen using for loop, right? If you have got multiple dimensional array, then how you are going to iterate with all the row wise. Okay, that also we'll see. How to extract particular value from the array. Okay, and how to calculate the determinant of the matrix. Do you guys know determinant of matrix? Quickly, someone if you remember. If I want to calculate determinant of, let's say 1 2 3 4 5 6 7 8 9, what I have to do? Determinant. Can someone tell me? This is a quick recap for you guys.
Sir, we will take 1 into B2, B3 and C2, C3.
Yeah. So you'll be multiplying like this, right?
Yes, sir.
Correct. So how do you multiply? 1 5 8 and 2 6 3, and later you multiply like this and subtract them. Correct.
Yes, sir.
Correct. So that's what is your determinant. So all the linear algebra calculation, these kind of functions are there in Numpy, which you can easily calculate rather doing by hand. Okay, and after that we'll see how to get the sign of like particular number, cosine of a number, tangent of any number. Correct. So you would have seen, right, some of the calculation in maybe in some of the subject, or especially you will be using in the, say, digital signal processing, where you will be very frequently calculating what is the sign of this number, these arrays, or cosine, or maybe in the control system also it will be used. Correct. So we'll see how to use them, and I'll show that with the help of plot also. It will be helpful, and couple of interview questions. Okay, so let's go ahead and start using it. Yeah, so this is a library which I was talking. Import numpy as numpy or np. So this is nothing but alias, right? I have already talked in the previous class also. So you can give any name here, because every time I don't have used numpy dot or something, right? I can use np as a short name. Let's import and get the version. So I have 1.20.3. You might have similar version or maybe higher or lower version. Anything is fine. Let's see what and all function it supports. See, it has almost close to Okay, let's see how many it has. 612 functions. Okay, so we are not going to learn all 612. A lot of things are like doing similar jobs, but close to 20, 30, or maybe up to 40 functions we'll see. Okay, so that is the one which you are going to use very heavily. Let's see how to create the array. So I'll create one array using, let's say, a equal to np dot array. And if you are going to create some empty array, you can just write like this. Okay, so it is, you're not passing any argument, right? That's why it is giving error. So what it needs, basically it needs some object, right? So I'm not passing any object, so I can just pass empty, because array you can create from the list, from the tuple, or from any kind of iterator values, correct? See here, this is your empty array. Okay, let's say I want to create one dimensional array by passing 3 values. See, this is the array of having only 3 values, that is 1, 2, and 3. What do you see here? It is just a list, right? In the matrix, what we saw, you have seen multiple rows, right? So each row is nothing but a list. And basically, bigger picture is what? List containing so many lists. That is what is your array. Okay, so let me create some more examples here. It has a lot of parameters. Okay, so let's talk about only this and data type. Okay, so that you guys can at least understand the basic and how to create it. So right now I have only 1 row and 3 columns are there. Let's say I want to create 2 by 2, 2 rows and 2 columns. How will you create? So you write, let's say 1 comma 2, and as I mentioned, you have a main list, and inside this we have list of lists, correct? I can write 3 and 4. See here, this is your matrix, and how many rows are there? This is your first row, okay, and this is your second row. And how many columns? This is your first column, and this is your second column. Okay, that's what it is. 2 by 2 rows, 2 rows and 2 columns. So if you remember my first class, right, I was talking about Python is a dynamically typed language, right? So the way you type, you will be getting okay, Lambda function I'll explain. I think I missed it, right? Okay, so the way you type, it will be recognizing that way. Let's say you are typing integer, it will be taken as integer. Okay, if you type in the float, it will be taken as float. So in the Numpy array, right, it provides a flexibility to the user to put any kind of data type. I can explicitly define, I want exactly float type, float 64 data, float 32-bit data. Okay, similarly integer 64-bit data, integer 16-bit data. So how to do that? So here you have something called, if you see the function, right, we have something called DType, that is nothing but data type. Okay, so I can just mention, so first of all, let's see what kind of data type it is. If we just print it will print this dot DType. Is missing here. Yeah. You can write like this, integer 8. Okay, you see here, DType integer 8. This is one way to do that. So what does it mean basically? I'll tell you a real-time example also. If I give 16, it is going to take integer 16-bit. Okay, so let's talk about like where exactly it will be helpful. Let's say you have created an array, and by default, it always occupies the maximum memory. Okay, that is float 64 or integer 64 based on the machine. So let's say you are processing the black and white image, right? So black and white image, as I mentioned, it will be represented in the form of 2⁸, that is 8-bit data. So maximum possible values will be from 0 to 255, correct? So for just to write 255 number, do you really need 64-bit? No, right? 255 can be represented in the computer with the help of 8-bit also. And why to go and why to occupy more memory which is not required? Unnecessary, you are occupying more space, right? So this will matter more because when you are processing large set of image data, right, it is occupying more memory. So unnecessary, you are creating or occupying more processing power or more calculation and eating a lot of energy, right, from the computer. So instead of doing that, you always do the typecasting. From float 64 or integer 64, you come down to integer 8. because that is good enough to process 0 to 255 number, correct? So that's where your data type will be very helpful. You need to do typecasting. Okay, so that is a real-time example. That's what you use integer 8 or integer 16. Okay, similarly, you can write integer 64-bit also. Okay. Now let's see, whenever you create array, what and all information you can extract from that array. Let me show you. So first of all, we'll get what is the data type. So these are different attributes. Okay, a dot DType. If you just type here, this pointing, then what is the shape of array? Let's print that also. What is the dimension of array? So ndim is nothing but number of dimension. And what is the item size? Okay, so what is the size of the item? Means how many elements are there in the array? Okay, then what else we have? Items. Okay, let's print them. Okay, let's remove this one. This should be good enough. Yeah, DType and shape. So DType is nothing but integer 64. That's what we had defined, correct? And shape is nothing but how many rows and how many columns are there, 2 by 2. And image nothing but number of dimensions. Since it is 2 by 2 array, okay, the 2-dimensional array, that's why it is showing 2. Item size, total how many bits has been, or it's not bits, basically it is how many bytes occupied by each item of the array. Okay, so we have 64-bit, that's why it is showing 8 byte. Okay, so since 4 items are there, so 8 multiplied by 4, how much? Oh, sorry, since each item is 8 byte, right? So each item is taking 64-bit data. That's what we have given here, right? Integer 64. That's what it is representing. So if I want to calculate how many items have been, sorry, how much memory is allocated for this array, can someone tell me? How will you calculate? I can use like this. Item size multiply by how many arrays are there. So let's say I use a dot shape, and shape has total how many data? 2 by 2, right? So I can just take 0 and multiply by 1. It should be fine. 32 bit. Sorry, 32 bytes. So total memory occupied by this array is 32 byte. Okay, that's how you calculate basically. Any questions so far in this? These are very important things. Okay, they're very basic, and until you know this, you cannot proceed for larger application development. This is very important. This internal thing of Numpy you should know. Definitely you should know. So you realize this when you are going to work on computer vision or signal processing. All fine, guys? Give me thumbs up.
Yes, sir.
Okay. Now let's see generate an array based on range of values. Okay. So we'll see that also. So let's say I tell you to generate, let's say 100 values or maybe 50 values from the array, or array of 50 values. How will you generate? So we have another function called np.arange, not arrange, a range. So this needs what is the starting point you want, what is stop point you want, and by default steps. So it is same as like what we saw in the list, right? Start, stop, and step size. Okay, so I'll give, let's say starting from 1, I want 20, and yeah, that's all. See here. So array of 20 numbers it will give me. Okay, because you have given the number, right? 1 to 20. Similarly, if you want to generate, let's say -10 to 20. See here. All the range of values will be generated. Okay, let's say you want 10 to 100. Every fifth value I want, okay? I can just write like this also. Because my step size is 5, right? So 10, then 15, then 20, then 25, like that. Any doubts so far? How do you calculate the values? It's pretty simple, right? So this will be helpful when we generate more number of arrays, right? So instead of writing 1, 2, 3 manually, we can directly generate using range function. Okay, so by default, as I mentioned, right, if you take, what is the data type of this, how much, memory it is taking. By default, it takes integer 64. I mentioned, right, by default, it will be taking the maximum memory available, okay, using integer 64. If some float values are there, then by default, everything will be typecasted to float, and it will be taking maximum value, that is float 64. So let's say I give 100 dot something. See, everything got converted to float, right? Because one value got float. Okay, so for float, it will be always a high priority. If any one of the value is float 64, it will be always converting all the remaining value. Even though it is integer, it will be typecasted to float 64. Okay, so these things you guys should remember. Now let's say I want to generate random number between, let's say, 1 to 100. How to do that? For that, we have another function called np.random.randint. Okay, so I want to generate random number. Let's say, dice, right? If you throw the dice, some random number will come between 1 to 6. I want to simulate that. How will you do that? Between 1 to 7, I'll give, because 7 will be always excluded, like the way we saw in the list, right? And I want, let's say, okay, let's see 1. I throw the dice once, see which number is coming. 3. If I run again, 2. So these random number will keep coming. Let's say I want to throw dice 100 times. Are you going to throw manually 100 times? It is going to be taking a lot of time, right? Manually, it is not possible if you're going to throw 1,000 times and record all the numbers. So better we put, I want to throw the dice, let's say 20 times. Let's see each time which number I get. See here. Okay, so this number is very helpful when you are going to generate some random number between particular numbers. Let's say 1 to 7 for dice. Okay, similarly, if you are shuffling the card, some particular number you want to simulate, this simulation will be very easy. Okay, so that's how you generate the random number. Now let's talk about the reshaping. So reshape is what? Let me just talk about this here. So let's say you have got an array here 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this is what? One dimension array. I want to make it 2D. Maybe I'll take 9. Is 9 also. Okay. And 3D, can we take? Okay, we'll see that later. So one dimension array, because it has only one row. Correct. I want to convert to 2D. So can someone tell him how to convert? Let's say 9 is not there, 1 to 8 is there.
So first row is 1, 2, 3, 4, and the second is 5, 6, 7, 8.
So 1, 2, 3, 4, then 4, 5, 6. You will take like this. Okay, let me remove this 8. 9. Okay, only 8 up to 8 is there. You told first you will take 1, 2, 3, 4, then 5, 6, 7, right? Okay, that's correct. So I can convert it to 1, 2, 3, 4, 5, 6, 7, 8. So this is perfectly fine. So remember, whenever you are converting from 1D to 2D, make sure that whatever number of elements are there, right? You divide exactly those many number of rows and columns, so that when you multiply them, right, that should be equal to number of element in the one dimension. Okay, so here it is 2 by 2. Oh, sorry, 2 by 4. So 4 into 2, that is 8. Total 8 elements are there. What else I can have? Another example. I can have 4 by 2. So 1, 2, 3, 4, 5, 6, 7, 8. This is also possible. 4 rows and 2 columns. Possible or not?
Yes, sir.
Yes, because it is same, like number of elements are same, right? We are not violating any rule. If you are creating, let's say, 5 by 2, then what will happen? We need 10 elements, but we are having only 8. So it is not possible. Correct? 6 by 2, not possible, because we need 12 elements. Okay. So 10, number of 8, number of elements are 8. You divide in such a way that your number of elements will be always equal to one dimension array number of elements. So let's say we have 2 by 4, 4 by 2, 8 by 1, 1 by 8. What else we have? Yeah, these are the only possible shape we can generate using this one dimensional array. Okay. Now let's say you have only 9 elements. So how will you generate? 1, 2, 3, 4, 5, 6, 7. Can someone tell me what are the possible ways to generate in 2-dimensional? What is the possible number of rows and values? Guys, please tell.
So 3:3, but it becomes Q.
So Priyansh, you're telling NP is not defined. Did you import like this? Import numpy as NP. If you're running from notebook, it should work. If you're not using notebook, then you need to install it. Okay, so please check that. Right, friend. Yeah. So what is the possible shape for 2D? Someone was telling the answer.
3 9 cross 1 1 cross 9.
Yeah, 3 by 3 is the one possible, and 9 cross 1 and 1 cross 9. Only these 3 possible shapes, correct? Okay, so bottom line is clear, right? Your number of rows and number of columns you multiply, that number should be equal to your total number of elements in the array. Okay, that is the thumb rule that you should remember. Okay, so let's reshape them. So I'm going to create random number. Let's say I'm creating 1 to 20. I want to generate, let's say 27 numbers. Okay. Now let's generate it. So this is nothing but your 1D only. A dot shape. You see here only 27 elements are there. If second elements are not there, means there's no column. It is just one dimensional array. Okay. How to make this 27 in the form of 2-dimensional array? So I can use a dot reshape, and under reshape you just give the total number of rows and column you want. So I have 27. So what are the factors? 9 into 3 I can give. Correct. I can give 3 into 9. What else? Any other number where we get 27?
27 cross 1.
Yeah. I think that's the only possible thing, right? See, 27 rows and 1 column. And here I can give 1 rows and 27 column. So once you are going to learn artificial intelligence, deep learning, neural network, right? These reshaping will be very helpful, because the whole play on the deep learning will be based on the reshaping of data. Okay, especially this one. Okay, any other possible values? 9, 3, 3, 9, 20. Yeah, I don't think so any other number is there. Okay, so you guys play with those values also. Okay. Now, if I want to convert this 27, why I have taken 27? Because how many elements are there? It's 3 by 3, right? Yeah. So total 27 elements are there in the cube. 3 by 3 by 3. Correct? So if I want to make this array, 27 array in the form of Rubik cube, how will you do that? So what I will do, I'll just take this and reshape 3 by 3 and 3. See here. This is your first phase, second phase, and third phase. So Rubik cube you rotate, right? So 3 phases are there, and in between there is one middle phase. Correct? That also you rotate, correct? So that is the value. So this is your front, this is your middle, and this is your back. Okay. So if you keep generating, right, only thing is, again, here we have number of rows and column, and how many such matrix you want. So I want total 3 matrix of 3 by 3. If I give 4 matrix 3 by 3, then it will become 4 dimension. If you give 5, then it will become 5 dimension. Okay. But only thing, remember, if you multiply all 3, that number should be equal to number of elements in the 1 dimensional. Okay. So the thumb rule will remain same. Any doubt, guys? How you reshape to any dimension? All clear? Give me thumbs up.
Yes, sir.
Okay. Now let's talk about linearly spaced values. How do you create? So this is another function which will give you, let's say you want to have 1,000 numbers between 0 and 1. How will you generate? Okay, so this function will divide that one in a way that whatever spaces or number, it will get a number which you can linearly separate those 1,000 numbers between 0 and 1. Okay, let's say between 1 to 5, I want 500 numbers. Okay, so it will divide a number, get the fraction, and that fraction it will keep adding in such a way that you will get total 500 numbers. Okay, so this number will also be, this function will be helpful when you are going to generate, you are going to create a graph where you want x values between these two, correct? Similarly for y also. So let me just show you how you create it. Then space. So here it needs some number. Let's say I want to start from 2 to 5. I want 30 numbers. See here. It has got one fraction, right? And based on that fraction, it has just kept adding that number. So this is your first number is nothing but this number. Okay. So 0.10 is the first fraction. 0.103 you can say. Keep adding and you will arrive to 5 by having 30 numbers. Okay. If you don't give any number, like how many number I want, by default it generates 50 numbers. Okay, with this is your fraction. Okay, 2 plus 0.06, 2.06, then again 0.06, you keep adding up to 50 number you'll get to up to 5. So okay, so if no number is given, then you will be getting 50 values. If you give number, it will divide in a way that total number you will get. Okay, so when I generate the graph, right, with that Matplotlib, I'll use it. Okay guys, so that's about linearly spaced values. Now let's talk about creating a specific type of array. So we do have direct function like zeros, ones, and identity. So how to generate np dot zeros, and here it takes shape. So I want 2 by 2, and shape should go in the form of tuple or list. Okay, so 2 by 3, and let's say 4 by 4, 4 rows, 4 column, only zeros matrix. Okay, so there are some applications where you need to multiply the whole matrix with the help of 0, right? So that's where zeros function will be helpful to generate that matrix. Okay, similarly we have ones. So what it takes, again it takes shapes. So 2 rows, 3 column, 4 rows, 4 column. It's only one matrix. It will have all the values as 1, correct? Can someone tell me what is identity matrix? Anyone remember?
Same number of rows and columns.
Okay, same number of rows and column, that's correct, because it is square matrix. But what and all it contains? Full zero, full ones, or only ones in diagonal? See here. So it needs only how many number you want. So total 4 numbers I want, so automatically you get 4 by 4, because only diagonal matrix will have ones, the rest will be zeros. Okay, that is what is your identity matrix. Okay, so let's see the next one. I, not necessarily a square matrix, only diagonal elements are set to 1. Okay, so let's see how to create that. np.I. So basically total, let's say I want 3 by 3. Okay, and I can give, let's say 3 by 4. Yeah, so it is not necessarily like it will be identity matrix and shape will be exactly square. You can give n number of values. Okay, so let's say whatever number is coming first, only first 3 number diagonal values will be 1 and rest will be zeros. But you will try to create the shape of whatever user has provided. Okay, so let's say this 3 by 4. If I give 4 by 3, see here. Okay, so whichever comes as first diagonal, it is going to generate those many number of ones in diagonal. by maintaining the shape. What is empty matrix? If you want to generate some raw data, just a matrix you want, so only some garbage value it will take. That is nothing but some raw data. np dot empty, and what in a shape. So I need, let's say, 4 by 4. It is giving me 1. You may get 0 or you may get anything. Okay. So as I mentioned, it is it is going to fill the data with random data. Okay, let me create 10 by 10. It is giving more, or yeah, you see some random values are there. Okay, so you may need this empty matrix also sometime, just for the practical purpose or demoing something. Okay. Now let's talk about transposing the matrix. So I'll create one matrix here, np dot random dot rand int 1 to, let's say, 10. I want 12 values. Okay, a dot reshape. I want to make it 6 by 2, 6 rows, 2 column. Okay, so this one I'm going to restore in the array called B. Okay, now this B is nothing but having 6 rows and 2 columns. Let me just prove it by printing them and print the shape of it. You see here, shape is nothing but 6 by 2, that is 6 rows and 2 columns. If I want to transpose it, how you can do that? There is one function called T. T stands for transpose. There is one direct function also, np dot transpose, and you give the number, give the array. So both will do the same thing. Whichever way you want, you can do that. I prefer this one because this is very short way, right? You see here, after doing this, what it is telling. If I just get the shape of it, see, row got converted to column and column got converted to row. That is what is your transpose. So this will be helpful, let's say, when you are transposing the image, right? So what will happen? All the rows will be converted to column and column will be converted to rows. So this will be, I think, 90-degree shift will be there. Okay, or complete shift will be there. Okay, so I'll take one small example and I'll help you guys to understand how this rotation works, how those Photoshop editor and all those things are working in the background. Okay. So that's about transpose, or I think I should do it right away. Let me create one image. Which image I should take? Okay, so where is that? I'm going to take one image, okay? So paint. Let's say I'm just drawing something here. You guys are able to see in this paint brush? Hello?
Yes, sir.
What is this? Now this should work. Let's say I just draw something. Just a smiley, okay? And I'm just going to save this image. So here I'll give test.jpeg. Okay, let me see if I can open. So for this, I have to import one library, which I'm going to show after this. Okay. So, but since I need to modify, I need to import right away. Import matplotlib.pyplot as plt. Okay. So plt.imread. What is the image? Yeah. Okay. So this is the array of that image. And since it is black and white, right? You see here, it has taken an integer 8-bit, correct? And I'm just going to use plt.imshow here. You see here, this is the image we generated, correct? So this is what? This is basically a Numpy array, okay? And that array is nothing but 0 to 255 number is having. You see here, these are all 0 to 255. If you see it completely right now it is not showing all because array is so big, right? You see this dot dot is nothing but continuation. So you will have some number 0 and some number will be 255. So 255 is nothing but your what to say, this white, and wherever you see black, right, it will be 0. So those black line are nothing but 0 and white background is nothing but what to say, 255 number. Okay, now let's do the transpose of this, see what happens. So I'll just use ar underscore t equal to, that is nothing but transpose, right, ar dot t. Okay, now let's plot this, see what happens. Underscore t. 3 by 3 for image data. What happened? Shape, okay, I could have taken okay, the third axis is also getting transposed. Just a minute. Here dot all rows, all column. Shape. Okay. All rows, all column, and just take this. Now this one, I have extracted the color that red, green, and blue, right? That component I have extracted. That's why it is showing like this. So what I'll do now, I'll just do ar underscore n dot t equal to ar underscore n dot t. Let's transpose it. And you see here, see what has happened. You did the image rotation basically. This is what I wanted to demonstrate. Okay, so you would have done same thing from the Photoshop also by clicking on 90 degree, 180 degree, right? But in the background, what is happening? They are just taking the whole array and just transposing it. Okay, so you can do complete shift also. How to do that? So what I will do, how to reverse the whole image? I can just flip the image like this, mirror image. How will you do that? I can take this equal to column -1, right? All rows and all column -1. Let's do this flip, see what is happening. See, it exactly mirror image. Okay. So these are the things which you will be doing with the help of computer vision, and computer is completely based on NumPy only. Okay, so these operations you guys should know, then only you will be able to achieve. Okay, any questions so far, guys? Did you get what I just explained, or was it too technical? But at least you can you got to know, right, what is happening when you do Photoshop editing, what is happening in the background. This is what is happening, I just showed you. Okay, all clear, then I'll proceed. Give me thumbs up.
Yes, sir.
Okay, so how to modify the array? Let's say you have the value here, where it went, np dot array a range, and I'll give 1 to 10. Let's say I want 20 values, and reshape them 5 by 4. Okay, so I got this value. I want to modify this value. How will you do that? Okay, so for that you should know how indexing and slicing work in array. So whatever we have seen in list, right, list tuple, it is exactly same. Only thing is it will be dependent in the form of single square bracket. Okay, so here is the syntax. So if you put a comma, right, so before comma it will be talking about the row, because row is nothing but a list, right, and column is also a list, correct? So after comma it will be column, and after before comma it will be row. And for row and column, whatever list and indicing you have done or slicing you have done in the list, right, same way you just do that. Okay, so how to do? Let's say if I do if I give column means what? All rows and all columns. Okay, if I give column comma column means here I want all the rows, and after comma it is nothing but column. So I want just column, right? So it is giving all rows and columns. Okay, now let's see if I give here, I give let's say 0, and here I give 1. What does it mean? I want 0th row and first column. That is nothing but 0th row is this, but in this I want first column. So how it will be? Let me just use pen and I'll show you. So 0th row is nothing but this one, and first column is nothing but this one. Okay, so what does it mean? Whatever is the cross-sectional area, right, that is only 4 will be written. This nothing but your 0th row, and sorry, first is this one. I made a mistake here. Take color. Yeah, 0th row is this, and first column is this one. Okay. So whatever is your cross-sectional area, that is nothing but 0, 1. Okay, that's how you extract the values. Okay, so if I run, see what happens here. See, we got 4. If I want this 7, what I have to use? Can you guys tell me? I want to get, let's say, this 9. For 9, what I have to give? I want to hear from you guys.
2 cross 1.
0, 1, 2, then cross 1. Yes, that's correct. If you're able to answer this, means you have understood the matrix slicing properly. Okay, so like that you can access any kind of value. Let's say I want to extract this 7, 4 and this 7, 4. Let me just highlight this. I want to hear again from you guys. I want to extract this particular part. What I have to write? Tell me. Any idea? So now from this list, I'm extracting only this part, right? So this is what? This is your one list. From this list was 0, 1, 2, 4, right? So 2 and 4 I want. 2 and 4 from this row. And from this column, I want 0, 1, 2, 3, and 4. From column, I want 3 and 4. That's all. This is what we have to arrange, right? So how will you write? So I'll write, I want from 0, 1, 2, 0, 1, 2, 3. From third row, I want 0, 1, 2, 4. Correct? So from 2 to end, I can give 0, 1, 2, 3. Sorry, third row. Third row, all, and column will be what? No. 0, 1, 2, 3. 3 and 4. This is also there, right? These two rows are there. So I can give 3. 3 onwards. So 0, 1, 2, 3. 3 and 4 both will be covered. That's what 3 column means. Correct? And here I want to give 0, 1, 2, 3. 2. Second column. 2 onwards. See here. So from third row, all, and from second column, all. So that's how we can extract particular values. So now if I tell you I want to extract this I of this particular puppet, how will you extract? From this image, I want to extract only this part. Can you extract that? What value you have to mention? You see the row. So row is coming from where to where? Most probably 150 to 250. That is your row, and column will be from 150 to 250. If you give that right, this whole particular image will be extracted. So when you filter the image right, you remove some part. This is what is happening in the background. Okay. Are you guys getting what I told? So this is what basically an array, right? From array, we are filtering only this part. And this, for this, you need to know in what row and what column you are extracting the value. Okay. So let me just make it more easy by, what to say? Since this is, this we can treat that as an image, right? Because image is nothing but a pixel value. So what I'll do, plt dot in show, and let's show this array. See what is happening. This is just image, this particular part. From this image, I am extracting this part. This is what I give, right? 3 to 4, that is this and this, and 0, 1, 2, 0, 1, 2, 2 to 3. That is nothing but a column. Same thing I did here, right? See. Correct? Any doubts so far, guys?
So,
yeah.
So, are we able to light a bulb with this process?
Could you repeat your question?
Sir, are we able to light a bulb with this process?
Light a bulb means I did not get that.
We can say that we have a GIF of lighting bulb, and we can exchange off bulb from and on bulb.
Yeah, you can do that. Why not? Because it is just an image, right? From image, you can just extract that part. Correct?
Yes, sir. Sir, can you please show it?
Okay, so just give me one example, then I'll tell you. Let me just increase the audio. I'm not able to hear properly. Yeah. So you are telling you have a bulb and you are just lighting it, correct?
Yes, sir.
Okay. So can you tell me like where exactly you are going to use that technique?
Sir, I had listened this question in some interview, like.
Okay, so basically you can just make 0 and 1, right? That's all. So I can create one small array. Let me just do that. So what I'll do now, I hope if I understood correctly, this is what you mean to say. np dot array, and let's say 0. Okay. plt dot show. Okay. I have to give it to 2-dimensional. Okay, so assume that this is your bulb which is in 0 condition, and now if I make this as 1, why it is giving white? It's supposed to be white. So zero. Oh, 255 I had to give, right? Not this one. Is a zero, and if I give 255, this should be white. That is also not coming. Let me figure it out once again. Okay. I think with the help of this also you should be able to simulate, because here what I'm doing, I'm just assume that this yellow one is nothing but a 255 and 0 is nothing but a black. Okay. And here this will be 0 and 255. So I'll just make it 0. This I'll make 0, comma. See here. So we are just toggling these, right? So this 0 was converted to 1. That is nothing but here your bulb is on and bulb is off. Is it clear?
Yes.
So this blue or not blue, basically this dark is nothing but your on. Oh, sorry, off, because we are representing this as 0, right? And the moment it becomes yellow, it has nothing but bulb. Your light is on, correct? So with the help of 255. So 0 to 55 if you use, you can simulate bulb on and off, light on and off. Okay. I hope I answered you correctly.
Yes, sir. Got it.
Okay, let's talk about arithmetic operation on array. So I'll just use, I think I already showed in the whiteboard, but let me just generate once again. One, two, let's say 5. I want to generate 4. Reshape 4 by 4. So 2 by 2. Because these are two arrays. This is one A and this is B. I want to do arithmetic operation. So what you can do, A plus B you can do. So what does it mean when you do arithmetic operation, right? Number of rows and columns should be same in both the matrix. Okay. So 4 will be added with this 2. This 4 will be added with this, like one-to-one mapping. Okay. So first row, first column element will be first row, first column of second element. First row, second column of first matrix, first row, second column of second matrix, like that. Okay. So similarly, you can do A multiply by B, A to the power B, whatever mathematical operation you know, right? Everything can be done. That's what is your arithmetic operation. Okay, so I want you guys to try this different operation. Okay. Indexing slicing I already showed. That is this one only. Now let's see how to iterate over array. So how we can iterate? Let me just see. I can generate using this. So let's say I want 10 and here 5 row, 2 column. Okay, so if you want to iterate, let's say each row of this matrix, right? How we can do that? We can just give for, let's say row, because whenever you iterate, right, it is basically fetching the first list, second list, third list. So those are nothing but a row only, right? So I can just give for row in A. Print ROW. This is the way you iterate. So separately you can print all the rows, individual rows. Okay, nothing much on that. Then later if you want to iterate over each element of this particular what to say row, then you iterate over these elements again. How will you do that? So row is nothing but again a list of elements, right? So for E or ln in ROW, print ln. See, I'm sure you guys would have done for I, for J in your computer programming language test, right? I'm sure you would have generated that kind of matrix. Okay, so this is what we are doing here. Okay, guys, any other question in this? Today's class will be extended. I hope it is fine. Because after that we have Matplotlib, right? That will be another half an hour or 1 hour. I hope everyone is fine.
Yes, sir.
Okay. Now, what is a statistical function? So those who know basics of statistics, you will be knowing like mean, median, standard deviation, all those things, right? So how you can do or how you can use those functions in the matrix is very easy. What you will do, let me just create this. Those who are going to do analytics and all, right, this will be very helpful. So let's say I generated matrix A. I want to find out what is the minimum value of this matrix. So what you can do is just apply the function min. Whatever is the minimum value, that will be returned. So minimum VCA, 1, no matter where it is present, it will just return. Okay. Similarly, I want to find the max value of this. Wherever it is present, it is going to return that. Let's say I want to get the mean of it. Mean is what? Adding all the values divided by total number of values. That's what you want. 2 dot it. So what it is doing, mean, basically it is adding all the values together. Okay, that's what this mean does. But let's say I am interested to calculate mean of only first column or only the first row. Then there something comes as axis. Okay, so by default it will calculate all. But if you give axis 0 means row wise, axis 1 means column wise. So how to do that? If I give axis equal to 0, see here, only 2 elements we got, right? This is nothing but column wise. You see here, it has added only the column. Whatever is the mean, you got this 2.8, and for this also whatever mean we got, it is added all divided by that, and we got 2.8. Okay, so 2 values we got because only 2 columns are there. Now let's say I have to calculate mean of each rows. So how many rows are there? 1, 2, 3, 4, 5. So total 5 value we can get, right? Just by changing the axis. See here. This is for the first row, second row, third row, fifth and fourth and fifth row. Okay, that's how you calculate. This is also going to be very helpful if you guys are running statistical analysis for the given data, row wise, column wise, or overall complete data. Okay, let's see a couple of other examples. We have something called standard deviation. Okay, this overall standard deviation. If I want x is equal to 0, equal to 1. Okay, that's how it works. So there are a lot of functions: min, max, median, then standard deviation, variance is there, covariance is there, n number of functions are there. I suggest you guys to just look for those functions and use it. Okay. Now let's say we have an array and I want to extract some values based on certain condition. How to do that? So we have something called where function. Let's say I generated this. I'll give some bigger value. Okay, 1 to 100. I want 20 values and 4 by 4 matrix. Okay, so I want to get to know the index of those values which is, let's say, greater than 25. How to do that? np dot where a is, let's say, greater than or equal to 35. See what it does. It is returning me 2 location, right? What is this location? This is nothing but your row location and column location. Let's go with the first value. Is it greater than 35? Yes. So what is this? I'm getting 0 and 0. So 0th row, 0 column is having this condition true. That's why we got this. Okay. Next value, is it greater than or equal to 35? No, right? Okay, then we have 97. Yes. So what is the row? 0th row and which column? 0, 1, 2, second column. 0th row and second column. Okay. So whatever array you are getting, that is nothing but your row index and column index. If you join them together, it is going to return me the value where this condition is true. Okay, so this will be asked in an interview if you want. So please understand this clearly. So how to extract those values? You just give this, because now I'm getting row and column indices. I can pass them as a bracket notation. See here, this is a value I got. The final value which you'll get, it will be flat matrix. Okay, not like same dimension will not be maintained because it is filtering the value, right? So dimension will be lost. Okay, there is another way to do that, or quick way to do that. Instead of using this, all you can do is a get the equal to 35. So internally it is doing same thing, whatever I just showed you. Okay. So let's say if you write like this also, it is going to return boolean true or false. This boolean true or false is nothing but this one. So multiple ways to do that. Okay, is all clear?
Yes, sir.
Okay. So let's see, only two functions I'll show: linear algebra, like matrix multiplication, which I showed in the whiteboard, right? And determinant, how to calculate. So for this we have, let's say, dot product, create a small matrix equal to np dot array, let's say 1, 2 and 3, 4. This is your b. Okay, b, let's say we have only this. So I'm going to multiply this. How to do that? So we have something called np dot linear algebra, then give dot. Dot takes what, a and b. Let's see. Np dot, yeah, dot is the function. Okay, a comma b. Why dimension is not matching? Two by two and not aligned. Two dimension. Okay, there is a thumb rule for doing dot matrix, right? What is the thumb rule? Do you guys remember? Okay, if you don't
So
remember,
row into column.
yes, correct. So number of rows should be equal to, no, number of columns should be equal to number of rows in the multiplied matrix or multiplication matrix, right? You see here, number of rows are 2, but number of columns should be equal to number of rows of this matrix. But here we did not do the same. Okay, so this is nothing but your row. So 1 row, 2 columns. It should be 2 row and 1 column. Then only it will work. So what we can do, we can just convert it to a matrix. Then it should be fine. Just write again. And this is, because the first row will be 1 and second row will be just 2. Okay, then this is a matrix. Yeah, now this should be fine. And if you do dot, yeah, you see here. So how it came? Let me just explain once again. We are having 1, 2, 3, 4. And here we are having 1 and 2. Correct? So 1 multiply 1 and 2 multiply by 2. How much you got? That is 1 plus 4. 5. You got 5. Then 1 multiply by 3, 2 multiply by 4. So 3 plus 6. 6. Oh, sorry, 8. This will be 1. We got 5, 11. That's what we got here, right? 5, 11. So that's how you solve the dot matrix. Similarly, determinant is nothing but, what is determinant? 1, 2, 3, 4. You multiply this 4 minus 3 minus 2. That is 6. That will be minus 2. Let's see if we get minus 2 or not. So this you have to use np dot linear algebra dot det. And det of what? matrix. What is my matrix? A. You got -2. Okay, guys, so that's how you calculate. Any doubt so far? Then we have one last topic in this.
No, sir.
Okay, so let's see how to calculate the sine and cosine value of given set of values. So I'm just going to generate np dot linear in space, let's say 1 to 100 or 1 to let's say 50. I want 100 values. Okay, we got 100, and let's calculate the sine wave of this. Basically, I will take the sine function and calculate the sine value of each and every value. Okay, so what we have np dot sine. If you give this array, it is going to calculate the sine. This is a sine value of each and every value whatever we generated, but it doesn't look. I mean, we are not able to interpret, right? It makes sense to plot them properly. So what we can do, plt dot plot a. Basically sine of a, so sine of a. Okay, see here, this is a sine wave. So let me make it more beautiful plot of it. PLT, I'm going to explain this in the next session. Fixed size 16 by 4. Yeah, this is much better. So you see why this kind of crank is coming here. It is not very smooth because we have taken the less number of sample. If you guys know Nyquist criteria, probably you can correlate. So to make it more smooth, what I'll do, I'll just take more number of samples. Maybe I'll give 300 samples. To reconstruct the sine wave, you need to have exactly 2 times, right? See, now it is much better, correct? So this is the way to generate the sine of using Numpy sine function, and whatever values you have, you can just get it. Okay. Similarly, let's say I want cosine of this. So what I'll do here, only I'll calculate cos of. So NP, let's say sine of 90 is what? 1, but cos of 90 is 0, and cos of 0 is 1. So you will see exactly opposite of this, cos of a. And let's plot them using red dot. See, I may not be generating from 0, so what I'll do, I'll take exactly from 0. Yeah. Now this will look better. Okay. So your sine 0 is 0, cos 0 is 1. You can see here, it is clearly telling. Correct. Yeah. You can give whatever marker you want. Dot dot. Okay. What else you can take? Yeah, that's what I wanted. So how to calculate sine of given value and cos of given values, and how to plot them. If you would have seen oscilloscope, right? This is what they do, that plotting. Okay, so what else I can do now? Let's take negative of this.
Are we able to plot the exponential?
Yeah, exponential also you can do. So let me plot this one, blue color or magenta color. See here, this is just taking the negative of cos. So what you told, exponential of this, right? So let's take np dot exponential of, you can plot log also. A, we are getting the value, right? So what I'll do, I'll use same thing, and here I'll use exponential of a, let's say black color. Yeah, it is suppressing because it is touching very high value, right? It's better to plot this separately. Yeah, that is your exponential. If you want log also, so you can plot log base of 2 or whatever. I hope it will work. Yeah, this is a log of 8. So whatever mathematical functions are there, right? Just calculate the values and just do the plotting. It is pretty simple. And Numpy and Matplotlib, it is very heavily used combinedly for plotting the graphs. Okay. Okay, guys. Though that's all about Numpy, and these are a couple of interview questions, so you guys can read it. I have already explained in all the previous cells. So you guys need 5 minutes break, then we'll start Matplotlib. 5 minutes break. We'll meet at 10:35. All okay? Give me thumbs up. कुछ बोलो यार. बोलोगे नहीं तो कैसे चलेगा?
Yes, sir.
Okay. Okay, then let's come back by 10:35. Okay, guys, I'm back. All of you are back.
Yes, sir.
Okay, then let's start Matplotlib. So we have already seen the demo, right? How to plot the sine wave. So I'll talk about a couple of more powerful graphs which you can generate with the help of Matplotlib library. Okay, so what and all plots I'm going to cover. So we'll see. This is not required. Okay, so we'll see line plot, scatter plot, bubble plot, how to plot the bar, horizontal bar plot, histogram, pie plot, and image plot we have already seen, right? So this is not required now. Okay, and what are the various properties of the plot, how we can edit them. So if you know the Matplotlib plot, then all other advanced library, right, which is developed on top of Python, which you can easily work. So some of the advanced library called Seaborn, Plotly, there are so many other libraries which they have developed on top of Matplotlib. Okay, if you know this basic, then you can work on any other library. So basic is very important. So let's go ahead and just check. So here first I'll explain a couple of important parameter of the graph. If you plot any graph, right, so what we need, let's say if we are talking about only 2D plan. Okay, sorry, 2D plane. Okay, so 2D plane means basically you have x axis and you have y axis, correct? So in x axis you need some data, correct? For each x, what is your corresponding y value, correct? Then for this value, what else you have? For this particular x value, what y value you have? Then you do the line plot, correct? This is line. If you want to do bar plot, then you can plot the bar, correct? So similarly, a couple of other values are there where you may have to plot a pie. So basically how much share it is holding. Let's say when I say share means, let's say total out of 100%, what is the share of, let's say 0 to 5, correct? So this will be shown in the file in the form of percentages. So that percentage will be shown here with the help of pie plot, correct? So we can see line, we can see bar. Then we have something called scatter plot. Okay, so scatter will also be helpful if you want to derive the relation between x and y. Okay, so let's say x is going high. Let's say x is going high, y is going high or low. Whether it is high or low, how you can put it? Let's say I am plotting some value here. This is your y, this is your x. So for each x, I am going to plot like this. So as x is increasing, y is also increasing, but at some point of time, y is suddenly increasing, correct? So this you can say this is exponential relation, correct? There could be some graph where you are directly plotting like this. It is very much shown as linear relationship, correct? Linear, that too positive. So if x is increasing, your y is also increasing. There will be some graph where you will have something like this. If x is increasing, your y is decreasing. So this is also linear, but negative linear relationship. Okay? So graph visualization is very important, which will clearly tell what exactly the relationship between two variables, between x and y. Okay, so that's where like visualization will be very helpful whenever you are going for data analytics or data visualization. So a couple of other graphs also we'll see. So those are basic. Okay, so what I will do, I'll just generate those library. I'm loading Numpy as NP, pandas as PD, matplotlib.pyplot as PLT. This is the library which you should have for plotting. Okay, guys. I hope everyone has imported this library. Once import, then only you will be able to run it. Okay, so let's import it. And after that, we will have some value. Okay, so let's say my x is nothing but, since x could be any variable, right? Let's say 0, 1, 2, 3, 4, 5, 6, 7, 8, 10. Let's say 10 value I have. For each x10, what is my corresponding value? So what I'll do, np dot range. So right now we don't have data, right? So we are generating. It's basically simulating. Okay. So I'll generate a range from 1 to, let's say, 50 data point. Okay. And corresponding y is nothing but np dot random dot rand int 1 to, let's say, maybe minus 10 to 60. I want total 100 values or 50 values. So number of x and y dimension should be same. So those x number of points are there, right? Similarly, corresponding same number of y points should be there. That's why I have taken 50. Okay. If you just print x, y. Okay. So for value 1, we have y equal to -2. For value 2, we have y equal to 55. Okay. So we have the value, but let's see the relationship. Okay. We'll do the plotting. So first and very basic is line plot. So plotting in Matplotlib is very easy. Okay. plt dot plot. So this plot is nothing but line plot. What it needs? X and y. Just give that. That's all. So what is happening here? Okay. This is, I will give 51. Because end is excluded, right? I have to give 51. You see here, this is a plot. So let's make it more bigger. plt dot figure. Under this, we have fixed size. It will tell like what is the aspect ratio you want. Okay. So far, this is the best one, which I always use. And plt dot show you should use to make sure that you are not getting this as printed. Without show also it will do, but in case you are not writing program in notebook, you are writing somewhere in the PyCharm or IDE, right? So you should use plt dot show, then only it will show. Okay. So this is one plot. What else you can do? For the plotting, you have something called marker. Okay. If you use marker equal to, let's say, dot. So it will make line as well as dot also it will make. Okay. Similarly, you have, these are some of the parameters which you can just play around. So marker, I can give, let's say, a triangle, upper triangle. It will shown as a triangle. We have something called capital D, that is bigger diamond. It will show as diamond. Okay. If you want to change the color also, we have something called color equal to, let's say, red. Okay. That way you can do. If you don't want to mention this marker and D separately, you can directly mention like this also. Red color with marker dash dot. You can plot like this also. With, let's say, I want B stands for blue color, K stands for black color, M for magenta. So there are so many color coding. I have some link here. You can just go here also. Okay. It will show all the chart type and their corresponding Matplotlib library where you can find all the options. Okay, so let's say we have K and here we have dot dot. Okay. So these are various things you can just plot it. Pretty simple, right? You don't have to write so many lines of code just to plot one line. Okay, so same thing I'm going to use for scatter plot also. Scatter is what? It is just a point. So instead of plotting line between this and this, it will just plot the data here. This is just a point. 1 point here, 1 point here. There's no line between that. That is what is a scatter plot. So what I will do, just plt dot scatter, and here also give x and y. That's all. See here, this is same point. This point and this point, there is no line. That's all. If you do the same plotting using this also, without giving, just give k. See here. Only thing is I have not made that big size. Let me just make it will be exactly same. So basically, line plot you can convert to scatter by just changing the property. Exactly same. Size is different, so I'll just show you how to change the size. Okay. Similarly, you can point the color here. Color equal to, let's say, red. That's all. Now, scatter plot is very helpful only when you are plotting the point size based on the data. Let's say some data value is very big, so I want to plot that point as a very big data, big point. If value is very small, I want to plot them small point. Then only it makes sense. And that plot is also known as bubble plot. So there is no direct bubble plot, but scatter can be converted to bubble plot. Let's see how to do that. So in this case, you are going to analyze each point, right? So we have to iterate over each data point of y. Okay. So for that, what we'll do for, let's say lm in y. Okay. Or what I can do, I can just use, let's generate the index idx in range length of the data. Okay. X. You can take x or y, but length is same, 50 only. So I will generate the length that is from 0 to length minus 1. After that, what I'll do, I'll go over each point. So take x of 0, under x of 0, what y of 0 we have. Correct? So this 0, instead of hard coding, what you do, put an index. Because first time idx value will be what? 0, right? So x of 0, y of 0, it will just get plotted. Okay. Similarly, it will go with the next value, that is 1. X of 1, y of 1. So each and every data point will get pointed. See here. If you don't give color, by default, it picks the random color. You see here, all things are colored. If you want to hard code color, you can just do color coding. I want each data point as red color. So let's say red. Okay. Now, since we have each data point, what we'll do, we'll see whether value is really big or not. Or let's generate the random size of the data. Since it is a circle, so we can use pi r square. Okay. So we have something called S is nothing but size. I want to multiply this. Pi is nothing but your 3.14. See, it doesn't mean that whatever formula I'm using, same formula you should also use. You can put any formula. Ultimately, size will get calculated based on the size of the data or the value of y point. Okay. R, let's say, consider R as nothing but data of y. And multiply 2 times. See, values are coming very big, right? So what we'll do, we'll multiply this with the fraction so that it will shrink. So this is with default. If I multiply by, let's say, 0.3, multiply, let's see what happens. Much better, maybe 0.2. 0.2 is better, right? Okay, now we have properly, like, bubble is created, right? Now you see all the data point, let's say some point is here, it is not visible. It may be hidden, okay? It makes sense to control the transparency of the point so that all the data points will be visible. How to control that? We have something called alpha. Alpha is nothing but controlling the transparency. So by default, it will be 1, which is not transparent, and minimum value will be 0. Because 0 to 1, you can put any fraction point. So let's say if I give 0.3, see here. This is what I was telling. Some data may be hidden, not visible. Right now, everything is visible, and this is known as bubble chart or bubble plot.
So what is the application of this?
Yeah. So application of this is like whenever you're plotting or you are analyzing some data, let's say year-wise population. So year-wise, definitely population is growing, right? If it is growing, it doesn't make sense to put that data in a single point, right? Maybe you plot that point in a bigger way so that you can always see the trend also. It is going big. That's why, you know, a big data is, what to say, big point is visualized in the data. Wherever data is very less, you point at this. Let's say here population is very less. Maybe if you go country-wise population chart, you might have seen in the newspaper also, right? They very frequently put this kind of graphs. Country-wise population, some country will be having very high population. Let's say China. For China, this bubble will be very big. Okay, let's say Nepal. If you take population will be very less, so point will be coming somewhere like this. So it gives more insight about the data. That's what is the application of bubble plot. Okay. So from now on, whenever you see bubble plot, just see what insight you get just by looking at the size of the bubble. Okay. Now let's say some point you want to highlight with the help of different marker. Okay. So what I'll do, I want to highlight some point which is less than 30 and in between 30 and 40. So what I'll do? So by default, I'll go here. If y idx is greater than 30, greater than equal to 30, and see what and all I can put here. You can do a lot of things just by putting the condition and less than equal to 40. Okay, if it is this, else go with default. Otherwise, if it is greater than 30 and less than equal to 40, I want to have marker as equal to, let's say, star. See here, and that too I want with blue color. Just want to highlight. See. Okay, so these are various applications. If you want to highlight some particular data point, which is like, I just took one example, right? Greater than 30 but less than 40. I want to highlight. But if it is not highlighted, it is very tough to pick those data, right? But if you highlight, it will be quite easy. You can randomly go there and just pick the data. Okay. This is one way of doing that. Another way, highlight the data, and since you are highlighting means it has some meaning, right? Put their values also. How to put the value? If it is this, we have something called plt.text. So plt.text is another function where it takes x and y position, and in that xy position, what you want to write. Okay, you can write your name also, but I would like to write the value of that data point. Okay, and it must be in the form of string. So we need to typecast as a string. So x, y. Okay, I copy pasted everything. You see here. Okay, since it is touching this point, right, what I can do, I can just put some offset by +2. Right, maybe too much. Yeah, this is okay. Or +3, just to shift the data little above the star. You see here, you can just play around and find the best optimal value. Now this looks better, right? So for this star, the value is 38. For this, 32, 32, like that.
So are we able to merge linear plot and bubble plot?
Come again?
Are we able to merge linear plot and bubble plot?
No, first plot I did not get that. Bubble plot and what plot?
Linear plot.
Linear plot.
Yes, sir.
You can do that. I'll show that later. Okay. So basically, if you just before plot show whatever plot you are, that's a good question. Okay. If you are using multiple plot, everything you put in one line, and just later you do plt.show, all the plots will get merged together. Okay. So let me just show here only, since you have already asked, right? I think it will make sense once I show bar plot. Okay. If you don't want to do, you can do here only. So plt dot, let's say I want to plot line also. I just plot here. Plt dot plot, and for plot, these things are not valid. You have to remove it. If you do this, see, it will be getting merged. Why it is not coming? Plt dot idx, ydx. Why it is not coming? I'm expecting that line to be here. Let me just make it simple. No issue. I'll just remove it and just have these two together. That should also be fine. So plt dot x color y size. Let's remove this. Okay. And marker is this. Okay, now if you plot this, this should get merged together. Because before plot show, I'm using multiple plot, right? Scatter as well as PLT, right? So this should also get merged. See here. Okay. If you do another plot where you want to merge, let's say, this dot also. Dot. And let's say y multiplied by 2 to the power 2. What is happening? Why it is not taking 2? Or okay, not a value, right? Okay, this is wrong. Yeah, so this is another thing. I think this makes more sense. So multiple plot, if you are using before plot, so everything will get merged in the single plot. Okay, guys. So that's about this plot. Now let's go ahead with the bar plot. So how to do bar? Then we have something called plt dot bar. Then just give a. See what it needs. It just need x, and height is what? Height is nothing but your y value, right? Y we can take as height, and we have to mention height equal to y. That's all. So let's use this. Okay, so some negative values are there, right? That's why you see this bar below x-axis, correct? So here also you can play with the, what to say, color equal to, let's say we have magenta. Okay, what else? If you do the line plot, your question, what you asked right earlier, just do the same thing. See here. Okay, the bar width also you can control, equal to, let's say 0.2, 0.4, makes sense. So a lot of things you can do. You just have to play with the parameter, whatever we are having. Okay. So this bar graph with along with line also you would have seen some trend they will show, and they will show whether trend is going down or trend is going up. Correct. So line with bar is very helpful to show the trend. You open the economic times, okay, then you will see all those graphs. At least bubble and bar with line you will definitely see. So bar horizontal plot, how you can do? You have, it's again very simple graph. All you need to do is we have something called bar h. That's all. Okay. Why it is not coming? X. What is it has? Oh, it has width, right? Okay, y is nothing but a y. This should work. Yeah. So same as previous plot, but only thing is you are plotting horizontally to save space. That's all. If you want to save horizontally, then you can go with this. Otherwise, vertically, you can go with the vertical plot. Okay, guys. So any questions so far? Otherwise, let's go ahead with the histogram. So histogram is nothing but, let's say I showed one example, right, where you are throwing the dice, correct? So let's say some numbers are coming. But if you want to know what number is coming, how many times, let's say I throw the dice 100 times, out of 100 times, what is the frequency of occurrences of number 2? Or how many times number 3 has come? That is what you are plotting, the frequency of occurrences of any particular number. And that is called histogram. Okay, so let's create that. A equal to np dot random dot randint 1 to 7. I want to throw it 100 times. Okay, plt dot hist and just plot it. That's all. So out of 100 times, my number 5 has come more than 20. That's what we can say. And number 3 has come very less number of times. Okay, that's what it shows. So histogram, always remember, it is the nothing but plotting the frequency of occurrences of a particular number in a given data set. Okay. If you put 1000 times, so more number of times you throw, probability of occurrence of that number will be high. You see here. So all will have, what to say, equivalent chance of occurring that number while throwing. If you throw less number, maybe 5 is coming more number, 6 is coming more number of times. If you throw more and more times, then number of occurrences of that number will be equal. So when I say equal, means chances will be very same, like 1 by 6. If you know the probability, right, then probably you will understand. Okay, so that is what is your histogram, and here let me just put 50,000. Okay, what is pie chart? As I mentioned, to show the share. So let's say I have one number where 1, 5, 3. Oh, let me generate array. Random dot and int 1 to, let's say 10. I want 20 numbers, or maybe 50 numbers. lt dot py a. See here. So which number is coming, like that percentage or proportion has been shown, correct? Let's say if you're just throwing 10 times. So this is as good as like histogram what you showed, right? But here with the proportion. So 100% number is from 1 to 10. Out of 10, let's say 5 is coming how many times? What is their percentage in for the data? So this is the way to do the default plotting. After we have something called labels. So labels is nothing but let's use A only. Okay. See here. So looks like number 8 is coming more number of time. After that, 7 is adding more. 8 is also like too many times, right? So that kind of percentage will be shown. Okay. We have something called, let's say I want to show 5 times. We have something called explode. Where is the parameter explode? So this is explode in nothing but let's say it's a pizza slice, you want to take it out, right? So I want to extract 7, right? So how you can do that? So we have to give, let's say 0, how many number of 5 there, right? So for each number you have to give the explode. So let's say first number I want to explode 20 times. Or the percentage, I think it is too big. I should give like this, yeah, like that. And the last number I want to explode by 0.3. So 0 to 1 is the higher number, right? So this kind of thing you can display. Basically, again, it is kind of highlighting that slice. You can just use the explode parameter. Okay, so that's about this pie plot. Now let's talk about editing the property of the plot. So we saw this plot, right? Let's go here. I'll take the line plot only to make it simple. Okay, so when I say editing property of plot means you have x-axis, y-axis, then you have the line also, right? So, and you have the title of the graph. So what is my x-axis representing? What is my y-axis representing? What is the name of the graph? That comes under editing the property of the plot. Okay, what is this x ticks? This is y ticks. What is the x number you see, right? That is x ticks. How we can play? So we have something of plt dot x level. X level is nothing but what is the level of x-axis. So I'll just mention x-axis. See here, we got x-axis, correct? Similarly, we can put y level. This is a y-axis. Sorry, this is y. Okay. Now we have something called title. plt dot title. This is chart. This is your line graph, correct? Now let's say I want to display each and every data point of this x, because here this point is touching which particular x point, that I'm not sure, right? Because it is not visible. So what you can do, you can play with the x ticks. We have something called plt dot x ticks. We just provide the x data. See here, each and every data point will be listed. Okay. If you don't want to do that, what you can do, just use x colon 2. Every second point I want to display. That is also fine. So that's what now you guys remembering or realizing, like how meaningful or how important it was to learn slicing and indexing. You will be using this or seeing this everywhere. Okay. So this we have already seen, so I'll remove it. Drawing a horizontal line, a vertical line, how to draw that? Let's see that also. We have something called plt dot, what is that name? I forgot the name of that line. Let me see if it is there. It's text. What is the name? Artist. Let me find. AX H line or vertical line. There will be V line. Yeah. So let's say I want to plot vertical line, right? So vertical line means you will, let's say you are plotting somewhere here. So let me just use this whiteboard. Okay. Let's say you are plotting one vertical line here. So what exactly you want? You need probably X position, and from where to where? Y. So Y equal to 0 to last. But your X position is constant, right? 9. That's what you want. Correct. So these are the parameters which you need to pass. So if you see here, it is taking X at 0. So X is equal to, let's say, I want to plot at, let's say, 19. Okay. And Y mean is what? Mean is, of course, from 0 to Y max will be, let's say, 60. You see here, this vertical line is plotted. So this crosshair, those kind of thing will be used only when you want to display some kind of threshold value. Let's say in this graph, my threshold value is 40. Okay. So this 40 I want to plot. So from X min to max will be there, but Y position is set. So I can just do X horizontal line. X is here, it will take X min and max. Min is 0 and X max equal to, let's say, 49, or maybe I'll give 50, and Y at what I want, 40. Yeah, I want 40. And I want color. This is threshold light, so I can highlight in the red color. See here. Excuse me. So any doubt, guys, so far how to plot these kind of line?
No, sir.
Okay. So now let's see subplotting and resizing. So what is subplot basically? So let me explain with the help of whiteboard. So let's say you have got one dedicated area here, okay, for plotting. So I have given this area and I want you to plot multiple graphs in this. So what you will do, you will divide this whole plot into multiple rows. Let's say I have divided into 3 rows, and let's say 3 columns. So total, how many graphs I can plot? Total 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. In the given area, I have plotted 9 graphs. So 3 rows and 3 columns. That is notation. So how to rename this, or how to name this particular graph? You will give 3, 3, 1 or 3, 3, 1. So out of 3 by 3, this is my first graph. This is 3 by 3 to second graph. 3 by 3 third graph. 3 by 3 fourth graph, like that. Okay, 3 by 3 fifth graph, and so on. 3 by 3, this is ninth graph. Okay, so let's see how to do that. There it is. Yeah. So I'll use let's plot this one. This is not required. So what I'll do, I'll just divide this whole graph into multiple graphs. So we have something called plt dot subplot. This is the function, and using this you can divide the whole area. Okay, so let's say I want 2 by 2, 2 by 2, and this is my first graph. Okay, all you have to do is just copy paste. This is my 2 by 2 second graph, and let's say this is magenta color. 2 by 2, this is third graph, and this is, let's say, yellow color. I don't know it will work or not. Let's see that. And this is red color. Green is also there. let's say this is this dot. You see here. Why fourth one is not working? Yeah, because I have overwritten, right? So this is first, second, third, and this will be four. See here. In the same area, you have put multiple graphs, correct? Together. You can plot the graph also. PLT dot, let's say bar plot. And this one, let's leave it. Bar, and here XY. And this one you can give scatter. Color equal to, let's say, green, and size equal to, let's say, 40. Okay guys, so I hope you like this particular subplotting. When you want to plot multiple variables right together, you want to display it together, it will make user easy to understand the graph properly. Otherwise he have to scroll up and down, correct? So better to plot similar kind of data in one graph using subplotting. Okay, so this is a way to plot, and let's say you want to save it. How to save it? There's very simple command called, before showing, you just do plt dot save figure, and you give the name, let's say subplot dot png, jpg, whatever you want. I'll give png. You can give the pixel width, density also. You can just calculate. Okay, something called DPI is there, density per pixel, or what is that? The density per inch. Okay, so DPI is more than, it will be more like high resolution kind of thing. So I will leave it to you guys, and I'm just going to save it by default. Okay, now it is saved, so it will go somewhere here. There's a subplot. Yeah, see here, this is the graph which is saved. Okay guys, so that's all about Matplotlib graph. Any questions so far?
No, sir.
Okay, so if no question, then let's quickly see the, what is it, Lambda function. Okay. Last class we could not do that.
Sir, can you provide some questions regarding the graph plotation so we can practice it?
Okay, graph question mostly in interview they don't ask, but in case they are asking, right, they will ask like, what do you know the graph? Like which library do you use for graphing? You say Matplotlib. Then they will ask which chart you basically use. You say scatter, line, plot. How do you plot? They will not ask much, because graphing mostly people use either third party, what to say, third party built-in, what to say, tool. Okay, and if they are not using tool, they might be using library. So in the library they might be using Seaborn, they might be using Matplotlib. So mostly in interview they will not ask questions. If they ask, only that much they will ask which library you have used. Okay,
Okay, sir. Okay, sir.
what is this? This is 14. So function we saw, right? What is this Lambda function? Basically it is the anonymous function. Why it is called anonymous? Because you don't have to explicitly define it. So other function we saw, right? Def, then function name, and passing the parameter, right? So here you don't have to do, and that's why it is called anonymous function. So how to create that? Let me show. So we have something called lambda keyword, and here the syntax will be like this. Okay, all the parameters, like the way you pass the parameter in the function. Okay, so parameter 1 I'll mention, and separated by comma, parameter 2, and so on, and followed by colon. This colon will tell your parameter is over, and now here you write the expression. Okay, this is one way of doing that. An expression using if-else condition also you can do. If, then this expression, condition, else expression. These two possible forms are there. And all the things like keyworded, non-keyworded, mandatory, non-mandatory, I hope you guys remember, right? Everything will still be applicable for Lambda also. So how to do that? Let's create that. So since it is going to create Lambda objects, I'll make that variable as lambda. Then we have something called, what is that? Parameter, right? So I'll give x and comma y equal to, let's say I am calculating x plus y. So x plus y will be calculated and automatically it will be returned to Lambda function or Lambda object. Okay. And you don't have to explicitly mention return keyword in the Lambda. And that is the beauty of Lambda. Okay. In the def keyword we used to mention, right? But here you don't have to mention. So let's create and see what Lambda has. Okay, I forgot to mention this. Okay, so this is your function main lambda xy. It takes two parameters xy. How to use that? Just call lamb and let's say give 10 and 20. It will automatically return 30. So the moment you call, it will go here, perform this addition, and whatever value is there, it is going to return. Okay, that's how you use. Now let's see a couple of variations here. So what are those variations? As I mentioned, all the keyworded, non-keyworded will remain same, right? So let's say you give x equal to this lamb. I'm just calling 1020. Up to here it is fine. If you call this, what will happen? Same kind of error, right? We need two arguments, but we are passing one. Correct. So those are still applicable, whatever we have seen earlier. So how to handle this? You can either pass y equal to 20, that is default, also you can pass. This is fine. Okay, or you can pass some value here. 40. This 40 will be overwriting this 20. Okay, this is one thing. Another thing, what you can do, we can take, we have seen this also, right? Star, let's say arg plus arg minus 1. What is this arg basically? What it will do? Do you remember that? Do you guys remember?
So argument.
Yeah, argument, but what it does basically? If you pass n number of parameter, what will happen? It will be taken right in the form of tuple. I have shown you guys, right? You guys remember or not? Under function, if you go here, I hope you remember handling multiple arguments. You see here, star arg. Correct? So that's what I'm doing. Those rules, whatever you have seen in the function, please revise that video. Okay, then you will understand. Those are still applicable to Lambda also. And this you will not find anywhere in the book. This is just using explorative thing I got to know. Okay, so this will be very helpful for you guys if you are using Quark. So Quark is nothing but your dictionary element, right? So I can pass keyworded element also. Let's say I'm passing here c equal to 10 and d equal to 20. Okay, so here I can pass d. That's all. See here. That's how Lambda works. Not much. All you have to remember, it is anonymous function, and the property of function, whatever you have used earlier, everything will remain same. And in the Lambda, you don't have to use return keyword explicitly. It will evaluate the expression and return the output. Okay. Let's see another variation. Let's say you want to using if else, I'll mention here. Okay, so here xy, and I want to do, let's say x to the power y if x is, let's say, greater than 20 or greater than, let's say, 5. Okay, else you write another expression. I want to calculate q. So what I have to do now? I just have to call those values, right? So let's say I call here 10 and here I call 5. So x is greater than 5, yes, so it will be calculating a square. And since x is what? I made a mistake. Yeah, this time I'm passing only one value. Okay. If I'm passing only x, So if it is greater than 5, it will calculate or basically execute this expression. If it is false, means this condition is not true, it will go to else condition and evaluate that expression. Okay, let's do that. So what is happening? This y, no, this is 2. You see here, since it was greater than 10, that's why it calculated the x. Now let's say I give here 3, 27. Why 27? Because x is less than 5. This becomes false. It will go to else condition and you take the q. Okay. So this will be very helpful when you have large set of data, like millions of values are there and you want to transform them. While transforming, this will be very helpful. Just put the expression, transformation expression, call the lambda, and it will evaluate in each and every value and just return the value, final values. Okay guys, so that's all about lambda. Anything else? Today is your last class. Any doubt, anything you have, please let me know. So now the forum is open for questions. How much you understood, where you have difficulty, and where, if you have understood, then where you are going to apply that knowledge. Tell me, anyone.
So first of all, we have to practice all these again and again.
Correct. So for practicing, I told, right, you whatever mathematical operation you know, just convert into Python program. That's all. That should be the best way to learn it properly. Okay. And once you become expert in basic, then you pick any random question from Google, solving Python questions. Take it, try to solve it, start building the logic, start writing the program. Okay. What else?
So we want to plot the graph of our subject domain, that is signal and system
Correct.
graph
Correct.
with Python.
You
And
try that, it will be easy. Signal system, I know that. So you will be getting x and y value. Some formula will be there. Do the calculation and do the plotting.
so
Okay. It will be, now I think you would have got in the mind, right? You can easily do the plotting, correct?
yes, sir.
Try that. Doesn't work anyway. WhatsApp group is there. Ping me and I'll definitely help.
Yes, sir. So I have a question. If we have to create a program where if I put any number over there, we have to get a binary digit of it.
Okay. It's a good question.
What
So let
should
me
we
just
do?
show you. You put any number and you want to get the binary of it, right? So I
Yes,
think
sir.
I have already shown it. Get the binary of any number. Okay, let me just, I'll upload this notebook, okay, for you guys. So let's say you have a equal to 100. You want to get the binary of it, just print bin of a. That's all. This is the binary. So 0b stands for binary and your number actually starts from here. So if you don't want to put all the things, then since it is a string, you can take the value from 2 to column. Okay. So just to remove these two unwanted characters for you guys. Is it clear?
Yes, sir.
Okay, so not only binary, you have hex also for getting the hex. For this, you have something called octa also. Yeah. What else? Any other question?
Not now, sir.
Okay. So please try that. Okay, practice. It needs practice. No matter which programming, practice makes a man perfect, right? In the programming language, if you are going to do that, correct? So please try that. Write all the program, whatever. Start with basic mathematical operation. That's all. That is the key for getting success in Python. Keep practicing.
Okay, sir.
And
Okay,
whatever signal system or control system you are reading, right? Whatever formula you see, try to convert that formula into. It is basically what multiplication, square, or any mathematical operation you are doing in the formula. Nothing else, correct? Put everything in the formula. Create the Numpy array, because all the signal system, control system, they will be using multi-dimensional array only if you're going to solve. With normal list and tuple, you cannot solve it. because you have to do the array operation, right? Taking one array, multiplying with another array. So one-to-one mapping, those things you have to do. Okay, then it will be easy. So that's why this particular topic I have taken for you guys, because I know it will be used in signals and control system.
Yes, sir.
Okay, I will upload the video after some time, and this notebook also you guys can download and try that. Fine.
Yes, sir.
If no question, then all the best for you guys, and keep learning. Any question, let me know. Put in the WhatsApp group so that when I answer everyone, other person will also get to know the answer. Okay, so they can also learn by that way. And all other topic in my channel I have already shared, right? So those who have not subscribed, please do subscribe and watch other videos also, especially tips and tricks you should watch. So because due to limited time, I could not cover everything, right? You guys can watch it and learn from there also. Fine. Share with your friends, other branches, anybody is fine. Because I'm sure everyone, at least, I'm not sure about mechanical and civil, but in the current trend, I have seen some people from mechanical and civil also trying to switch to data science. They want to learn Python. They want to get into programming. So share with all of your friends, no matter which branch they belong to. Let them also learn. Okay. And I have other Telegram channel also. You guys just share the channel link. Let them join. Put their queries. I'll definitely help them. Okay, guys. Then let's find out. Thank you. Bye bye.
Thank you, sir.